There we go. Hey, everybody, and welcome to our first CTO Roadmap call. I'm excited to have you all here today, so thank you all for joining. We've just got a couple more people joining as we start the session. For those of you that don't know me, I'm Laura Tchaikovsky, and I lead the developer community initiatives here at Dragonfly. So whether you've been with us from the start or this is your first Dragonfly event, welcome, and thank you for joining us here today. We've got something really special planned, and who better to lead the charge than our very own CTO, Roman Gershom. He'll be sharing the inside scoop of the history of Dragonfly, how it all started and where we're headed. You'll also hear why Dragonfly is a real game changer as a Redis replacement, the latest features we've rolled out, and how Dragonfly helps cut down operational costs. We'll also be looking at Dragonfly real-time data processing capabilities, the infrastructure advancements, and more importantly, like how you can help shape the future of Dragonfly by providing us some feedback. Please do submit your questions during the session, and I will answer them all at the end of the presentation, just to help us for the continuing of all the session and the topics. Thanks again for being part of the community, and now I'll hand it over to Roman. So without further ado, Roman, over to you.
Yeah, hello everyone. Very happy to be here. Let's begin. I know we launched this project more than 2 years ago, and it was quite a journey. I can say that I was a Redis user myself for several years. I have never been an expert, but then I joined an Elasticache team at AWS and had a chance, a privilege to kind of learn about various issues that the customers of Elasticache had, learned also provided my insights. I was a principal engineer on the team, and of course, not all workloads had issues, but those with performance and scalability problems were the hardest to fix. And I had a theory that those problems were caused by the original, by the limitations of the original Redis design. And I had lots of discussions within the team, but eventually I decided that it's better to innovate within the startup ecosystem. And I joined forces with Oded, who is my longtime friend and a colleague. We worked together for several years before. And we co-founded the project, and we launched it in 2022. Today we have more than 25,000 stars. We have thousands of teams using the project across the globe. We have a cloud service. We have customers. It looks very nice. Laura, can you skip to the next slide, please? So what are the strongest issues? Strongest suits of Dragonfly. So first of all, scalability. When you add additional small shards to a Redis cluster, for example, it's not always possible to address the fundamental scalability issue in production. Moreover, in some situations, it's not even possible to use Redis cluster for different reasons. And the only way to scale your workload is to go vertically. And luckily, Dragonfly is what it does best. It excels at vertical scale, providing a robust and efficient solution where horizontal scale can be too costly or ineffective. Also, performance. Dragonfly reduces latency, and we focus on P90 and P99 levels of latency. And those are the most important ones for teams that strive to maintain high quality standards for their service. I can tell that our cloud users, for example, they report almost magical experience when they switch to Dragonfly and see how their latency issues just disappear with Dragonfly. it's really nice to see and witness. Cost efficiency, we'll talk about it a bit later, but even like if you look at Dragonfly technology, so it adjusts to any hardware configuration. So, for example, if your workload is throughput intensive, you probably want to use instances with high CPU to memory ratio. And if your workload is a bottleneck on memory, you probably want to use instances with low CPU to memory ratio. And in any case, because Dragonfly adjusts to any hardware configuration, you can just focus on choosing the right configuration for your workload and thus minimize your hardware footprint and eventually reducing your infrastructure costs. And last but not least, management complexity. If you ever run a Redis cluster, you probably know that it's not a simple thing to do in production. And I can say that our first early adopters from 2 years ago were those teams that opted for running Dragonfly in single node configuration. And instead of taking their chance with Redis cluster. And one kind of extreme example that I remember, one of the teams shared this with us. They switched from 128 shard cluster to single node Dragonfly that ran on a huge machine with 1 terabyte of memory. It was amazing to watch. Now, if we talk about Dragonfly philosophy, our team philosophy, basically we strive to build an in-memory store without limits. And I'm not talking only about capacity limits, it's also about any software-related bottlenecks that stand between you, a developer, and your hardware server. And for that, we focus, when we develop Dragonfly, we focus on making sure that it fully utilizes all the resources of the hardware where you run it on. So that includes, of course, CPU, memory, and disk. So in 2022, we made all these optimizations with multi-threading and everything. And so we handled the CPU efficiency. In 2023, we wrote lots of data structures that kind of part of Dragonfly code base, and thus we reduced the memory footprint. And this year we started looking at disk interactions, namely SSD tiering, and I will expand on it a bit later. By the way, feel free to kind of ask questions if you have. I think Laura has the ability to kind of take them from the chat or the queue, right? And we can go over them during the end of our talk.
Yeah.
So if we are talking about like the Dragonfly architecture, how we achieve such efficiency. So Dragonfly adopts a shard per thread architecture, meaning that the Dragonfly process launches multiple threads. Usually it's indeed a thread per CPU. And we call those threads shard threads because they manage all the entries of the data store. And each entry, each key is managed by exactly one shard thread. And the goal, the purpose of those threads is to efficiently execute all the data store micro operations. Now, those micro operations are not the same like Redis commands, and the TCP client connections do not communicate with those shard threads directly. Instead, there is a very slim and efficient virtualization layer, which we call a coordinator layer, that also resides inside Dragonfly. And the purpose of this layer is to compose Redis-specific operations and to provide the original strong consistency guarantees like atomicity and everything for all the operations implemented inside Dragonfly. So basically, if you run mset, mget, any other multi-key operation like z interstore, this coordinator layer knows how to compose them by communicating with those shard threads and provide the same semantics as if you're communicating with a single-threaded Redis. So the look and feel is absolutely the same like with Redis, but it's totally a different architecture and totally different implementation. And of course, you are welcome to check our documentation on our in our repository under docs folder. We have quite a few documents there. Yep, we can go to the next slide. So we talked a bit about cost efficiency of our community version of Dragonfly, but during this year, we launched Dragonfly Cloud Service, and our cloud customers benefit a lot from cost savings on our own service, and they actually benefit twice. So first, our prices per gigabyte of memory are lower of those of other cloud providers or service providers. And by the way, you can see the example of the workload here on the slide. This one is a throughput intensive workload, just an example. And you can see how it compares in terms of absolute pricing with other service providers. So I mentioned the first benefit, just absolute prices per gigabyte, but also, due to Dragonfly technology, you benefit from buying less hardware for the same workload that you need to run. So those efficiencies are accumulated, and everything is returned to you as a customer. Cool. So we talked about the architecture and the cost savings and all the benefits of using Dragonfly. I would like to kind of cover what were the latest advancements of the team. We've implemented or finished implementing all the JSON comments. We had quite a few gaps in our comments coverage, and we are striving to close these gaps. So JSON comments were all implemented with JSON merge and mset were the last ones that we finished. We also finalized the implementation of our advanced authorization controls or ACLs. We also implemented, and it was completely like a request coming from community, we decided to implement support for Memcache API together with snapshotting and replication. So now community teams run their Dragonfly instances that speak Memcached, but still benefit from all the advantages of Dragonfly, meaning they have high availability option, they can regularly snapshot their data, and Dragonfly is the only source available project that supports all those capabilities and also compatibility with Memcached. And we also finalized our APIs for cluster support, and we are going to launch cluster support as part of our cloud offering later this year, probably in a month or so. I can say that we decided to pull out the management functionality of our cluster support outside of the Dragonfly code base because we believe it's much more. It's architecturally correct not to mix data plane and control plane functionality and have them separately. So implemented management functionality as part of our cloud control component. But Dragonfly has support for all the low-level functionality that is needed for cluster mode, and everyone in the community can step up and just implement those automatic controls if they want. They can use our Dragonfly operator for that and just extend it to this functionality, or they can just write a standalone service. Again, if they want something architecturally similar to Redis Sentinel, for example, it's all possible because Dragonfly has all those management APIs that can change its state when it runs as part of a cluster configuration. That's about kind of latest features. And last but not least, SSD data tiering. And it's something that we kind of dreamed of to release since the beginning of the project. In fact, version 0.1, the one that was released on GitHub in 2022, already had a small POC of SSD data tiering functionality. And we kind of pushed it back, but luckily this year we had enough bandwidth to really focus on that, and we released this summer our beta, this feature in beta, and I would like to spend kind of the rest of our talk, like to talk about this feature and explain why I think it is important and how it is different from all other implementations of SSD data tiering. So we can, of course, use SSD or any disk for several purposes. One of them could be durability or persistence. So SSD data tiering is not that. We use SSD capacity to reduce costs, and basically Dragonfly, if configured correctly, can use SSD capacity together with memory to provide this unified in-memory storage with both disk and memory fused together, and it's completely transparent for a user. They get the same look and feel like using a pure in-memory store. And Dragonfly put lots of focus on two very important metrics, which is high throughput and low latency, even if a disk is involved in query processing. So it was very important for us. And that's, by the way, how we differentiate our implementation from others. And you'll see the results on the next slide. Yep, here you can see how we compare against two other implementations of SSD data tiering. One is Memcached Xstore module. It's an open source implementation, and another one is proprietary Elasticache data tiering implementation. And we compared ourselves on the same instance type on AWS, instance type that has roughly about 30 gigabytes of RAM. We loaded it with 90 gigabytes of workload, so much higher than the memory capacity. And we performed read-only load test on 3 systems, and you can see those results. It's you can see how different Dragonfly is in terms of performance compared to both Memcache and Elasticache. And you can see also that it's not just in relative terms. The latency of Dragonfly is really good, and it's very kind of close to pure in-memory behavior. Of course, there are limits. When you use disk, there are IOPS limits, especially on cloud, that kind of regulates how much IOPS read request you can send to a SSD, but still within reasonable, workload, you can get a very good results. And of course, the capacity or the scale of your workload can increase if you use stronger hardware or bigger instances. I can say that we used AWS instance in order to compare us with Elasticache to be on the same side and to provide a fair comparison. But for example, on GCP, the IOPS limits for local SSDs are much higher, so you'll get much better performance with Dragonfly, for example, on GCP, with a comparable instance with local SSD. So we had lots of kind of technical innovations within this feature of SSD data tiering. But I would like us to focus on a single component, which is the IO engine inside Dragonfly that provides those advanced capabilities. And I want to explain how it is different from other systems that I know, like MMCached, and why we are so much more efficient. So on the left, you can see how the shard thread, the thread that I mentioned before, which executes all the micro operations, how it executes read operations that are piled up on the thread. So here you can see there are 6 read commands or get commands. So it's if it's a pure memory configuration on the left, it just reads from memory, so it's very fast. Let's say each command is performed in 1 microsecond. So in total, you'll spend 6 microseconds to finish all of them. It's clear. And on the right, you can see how it is done if it's a synchronous access to a disk involved as part of the read execution. So if every GET request must fetch data from disk, then with synchronous API, synchronous access to disk, you'll spend, let's say, around 20 microseconds reading each blob. So in total, it will be 120 microseconds. And you can see how latency piles up, even though during the time when a thread waits for the IO response from disk, it can't do anything. So it's like idle CPU that is not used, and still the latency is piled up because we're waiting for disk, and it's just aggregative. And Linux, up until a few years ago, had only a synchronous API, and that's how, let's say, Memcached implements its own IO engine and uses this synchronous API. And you can see how it can hurt your P99 latencies very easily if you have lots of traffic coming into your system. Now let's see how Dragonfly compares to that. So again, you can see how on the left, how in memory system works very fast, how in the middle, how synchronous API works. But Dragonfly uses asynchronous API that was released just several years ago. It's called IO Uring and was developed by a very talented team of kernel developers led by Jens Axbo. And this IO-Ring API allows you to issue asynchronous requests to disk. And it's unfortunately just only Linux APIs, so we are compatible only with Linux systems. And using this API, you can execute all those read requests from disks and return promises, which are kind of unrealized results from the IO request, and return them to the coordinator layer that I mentioned before, which is called like coordinator layer that composes all the commands. And basically this shard thread can execute as fast as possible. And now it doesn't use 120 microsecond in overall, because each operation takes only 20 microseconds and all of them are starting immediately. So I can just issue asynchronously 6 get operations, and they will be sent to the coordinator layer, and it will be blocked for 20 microseconds. But basically our tail latency will stay very controllable, very predictable, around several thousands of microseconds. And this way we also reach much higher efficiency when we communicate with disk. Now it may seem like a very easy thing just to replace your API call and to be done with it, but it's not like easy. Actually, the whole architecture of this feature was built upon the assumption that we'll use asynchronous API with implemented special data structures that still make sure that we provide atomic and strongly consistent computations, even when they're involving disk. Basically we maintain the same semantics with like with in-memory data store. It was super important for us. That's a kind of very short overview of how SSD data tiering works. Hope it was interesting.
Yeah, we have some questions after coming in, Roman, throughout the session. So I'm going to take them in order. The first up is from Anu here. Can you share the Dragonfly vision in the upcoming AI age, vector, hybrid search, etc.? And also hi to Anu, you're based over in India, so thank you for taking part in joining us in the session.
We are going to implement those features. So first of all, we already have vector search functionality. I know it's kind of very trendy today to provide this functionality. All data store, all database do that. We will also work on implementing those features, but for us, it's very important that the foundational architecture of Dragonfly will work very well and in a very stable way. We put stability of the data store of Dragonfly as our highest priority. Once we feel that we kind of covered all the bases and all the basic commands are implemented and everything works smoothly, we'll continue with implementing the advanced operations. So again, we already have vector search, and it's quite good actually. We use a standard algorithm that is usually used for in-memory data stores for that, which is it's called hierarchical neighborhood small world algorithm, if I remember correctly. We also have the structured search API. It was actually released exactly 1 year ago and was immediately adopted by the community. And we have it supported as part of our cloud offering, of course, and we have cloud users using Search API. So yeah, we are going to invest into all those things, but we kind of playing long-term game. We're not in rush to be trendy or to do what shines, and just want to do high quality work and continue at the pace that we feel comfortable with.
Cool. Thank you, Roman. I appreciate that. This is a shout out to Letzia, I hope I pronounced that correctly, from Brazil. They just said they can't wait for Dragonfly on Azure. So I'm sure that's coming down the line.
Yeah, we are going to release Azure support this quarter.
Excellent. Thank you. And hello to Brazil. We have another question coming in from Ray. Hi. I have a question. I think normal memcached is quite fast. What is the speed difference compared to Dragonfly's memcached? And will memcached data disappear when Dragonfly is restarted?
Good question. Yes, actually, memcached architecture is quite good, and I think for synthetic load test, you won't see lots of difference in performance. At some point, by the way, you can start seeing the advantage of Dragonfly and share nothing architecture that Dragonfly uses underneath. But in some cases, it will be almost the same, I would say. But again, you benefit from all the other features like maintainability features. You kind of mentioned this, like you asked if memcache data disappears when Dragonfly is restarted. So it doesn't have to be. So you can, for example, pass a configuration option that will snapshot Dragonfly periodically, or just snapshot Dragonfly when it goes down in an orderly fashion, and then upon restart it will load it again. Or you can use high availability setup that it's not possible to do with memcache, and again it will just work. You also can monitor Dragonfly using open metrics tools directly. So Dragonfly has a HTTP port metrics URL, and you can just plug into your what's the name of the the monitoring system? Wow, I have a blackout. Never mind. But like the standard open metrics systems to just integrate with Prometheus, integrate with Dragonfly, of course. So you have info command that is much more useful than memcache stats command. So you have all this, and also you can actually run the regular Redis commands in parallel to your memcached port. So, like, for example, you want to check what kind of entries you have in your data store, you can use scan. You can use sorted sets. Of course, you can't access them via memcached API, but you can add them. So you can do all this mix and match and all this flexibility with Dragonfly, and they use Redis commands and memcached in parallel.
Cool. Thank you, Roman. There's a nice comment from Anu again. So beautiful engineering design reminds me of Tiger Beetle, which also uses IO Uring. So I'm sure the engineering team will appreciate that. And shout out to Ari and all the engineers that make Dragonfly what it is today, and through Roman as well. So thank you for that. Another question from Ray. Where's it gone to? It just jumped on me. Oh, sorry. There we go. Will data spots happen? Will data hotspots happen? And what should I do if this happens?
Yeah. So it's all about probabilities, right? With a single thread, it's going to be stressed at some point. I mean, okay, if you are running Redis and your workload is small enough and you don't have any performance problems and your latency is great, I mean, you probably won't use Dragonfly, and it's totally understandable. Dragonfly is meant or designed to be for medium, large, huge workloads where efficiency matters and for predictable performance, right? And how so with single thread, you just have much higher probability to reach those hotspots. When you spread your load across 4, 8, 16 threads, right? Your probability of hotspots reduces dramatically. It, of course, still can happen. I mean, there is no, let's say, you start, workload that, I don't know, reads and writes it into a single key. So, of course, you'll have this, hotspot with a single key. And, of course, you may even saturate this specific thread that handles this key. That's the kind of the reality of the trade-off of this architecture. I still don't think that you'll have much better results, let's say, with memcached architecture, any other or KeyDB architecture that uses multiple threads to access the same key, and then it has contention, and you burn CPU with contention. So I think this trade-off is reasonable, and you need, as a application developer, you need to make sure that your load is spread as uniform as possible. You don't have huge data sets, and basically, still make an effort to build a scalable and efficient architecture upon Dragonfly, right? By the way, I did some experiments of running memcache, like tier benchmarked, memcache tier benchmark, sorry, with a single key, and I still got very good efficiency numbers, but at some point, it will saturate.
Cool. Thank you, Roman. Another nice comment from Adrian. Thanks for not joining the AI hype train and building a great product. So again, thank you to our engineers. They do a phenomenal job of doing an amazing job of building Dragonfly. So thank you for that.
We will join the AI hype. We will join, but we just want to do it in our time and to make sure that everything works well.
So we've got we've got people from all over the world here today. So thank you for joining us all. This is from Darist from Vietnam. Any plans to support data structures like time series, countmin, sketch, topk, and T digest as Redis 8 will? Ooh, that's a question.
Really? Redis 8. Okay, Redis 8, not Valky. Okay. We are not going to shoot in all directions. So basically, we try to be very data oriented, and we prioritize tasks that coming from community. And by the way, you can check it out. People ask for things, and we implement them, and this is how it works. But we still prioritize things, right? We have limited resources. We want to make things that are well tested. And what can I say? We do not have lots of requests for time series. We had quite a few, but it's not like a major focus of Dragonfly. I hope at some point, when our usage grows, our traction with the community grows, our cloud service will grow, we'll have enough resources to invest into these features as well. But I don't think it's going to happen in 2025, for example.
Thank you. Darius has a follow-up question. Thank you for all the questions today, folks. I really do appreciate it. Regarding Dragonfly Cloud, as far as I know, the pricing model is memory-based charge. So any upper limit of requests per second for a specific Dragonfly instance?
We do not regulate throughput, and everything that the underlying hardware provides, we give back to our customers. we had lots of discussions whether we should guarantee or sell throughput, but I don't believe it is possible because a single API call to Z range is completely different from set or get API calls, and also set and get API calls of 1 megabyte value is completely different from 64 byte values. My point is, at the end, the developer team, the DevOps, they know their workload in the most intimate way. And usually the way I provision resources as an architect, I try to run something in staging environment, see how it works, see if we over provision or not, and then custom fit hardware towards the use cases that I'm trying to run, and advise to do the same for our customers. So right now we provide two tiers, at least two tiers, and we have custom tiers as well. Some of our customers also request custom hardware configurations, and we provide them with very fair pricing. We're very transparent about our pricing as well. And basically those tiers provide additional CPU power. And usually most of the workloads are memory bottlenecked. So I suggest people start using either standard or enhanced tier. And if it's not enough in terms of CPU, just talk to us and we'll find for you the best possible hardware configuration and the most cost efficient one. And again, cost efficiency is super important for me as a performance engineer, and I would like that our customers will benefit from that, from our philosophy, and we'll make the best effort possible to fit any hardware available on the specific cloud to your needs as a customer.
Amazing, thank you. We've just enough time for one more question, and I've just also left a note there. If everybody liked this event, it's our first time running this kind of roadmap CTO call with Roman, and we plan to do potentially like once a quarter. If this time zone works for you, because I can see there's a lot of people here from the APAC region, please let me know. You can either leave me a comment here or drop me an email, laura@dragonflydb.io. I'm always looking to make amendments or changes to stuff. So thank you again for joining. But here's the final question for the show. It's from Darius again, a follow-up question for supporting more data structure. Any plan to enable module plugins like Redis so the community can add more data structure without waiting for your team?
It's a good question. I think plugin system in Redis was not done because the maintainers wanted to make it extensible or like to unblock the development of Redis. It was done because of the licensing reasons mostly. Our license is very open, and if you already invest an effort to build a functionality into Dragonfly, you can just contribute it to the core project and add this API, and you can talk to us. In fact, we had such contributors like I don't know if many of you probably don't know, but Dragonfly supports a very interesting and very narrow API that allows rate limiting. Okay. Now, I don't know much about rate limiting, but apparently there is very advanced algorithms around rate limiting called the leaky bucket algorithm. I didn't know a lot about this, but someone who needed this functionality asked to integrate this functionality into Dragonfly, and I told them that I can't. I don't know this algorithm, and they pointed me to the open source model, Redis model that implements that, and they said that I don't have capacity to kind of implement this. Back then, it was a very small team, basically me and maybe another 1-2 engineers, and that person just volunteered and they rewrote this functionality, and now Dragonfly, as part of Dragonfly core code base, Dragonfly has this command for rate limiting, right? We just implemented and we integrated it. So I advise people to do the same, and it will be much easier, simpler for everyone just to do it with our core database than for us to develop the model framework and to expose APIs. The thing is, it's not so easy like with Redis to implement commands. So it really depends on the command. But for many commands, it's very complicated. And I didn't find an elegant way to how to abstract away this complexity of shared nothing architecture and to provide a model API. And again, I don't think it's needed because of our licensing. So basically just come, open an issue and volunteer to implement it if you want, and it will be part of Dragonfly codebase.
Thank you, Roman. I appreciate that. And I know that in the past, we've had Anu, who's been one of our top contributors of the month as well, who's just joined on the show today. So yeah, we do review all the code. We also, myself and Joe, our developer advocate, regularly reach out to community contributors. So if ever you are interested in getting more involved, either drop me an email. You can join us on the Discord channel. We're happy and willing to work with anybody who's got any ideas as well, at least point them in the right direction. I want to say thank you again to everybody who's joined today. It's been a really successful show. And I look forward to hopefully running the next one next quarter with Roman again. So thank you, everybody, for taking part and submitting all your questions. We greatly appreciate it. And have a wonderful day, folks. Bye.
Bye-bye. Thank you.